Good morning, afternoon, and welcome to a video on angle addition postulate. So, we have two learning targets today. One of them is to learn about the angle addition postulate and find angle measures. The angle addition postulate is so similar to the segment addition postulate, except we're dealing with angles. And then we're going to be talking about an angle bisector in part 2 of our video. Alright, so let's take a look at this connection to astronomy. I love astronomy. So the astronomer Claudius Ptolemy, in about 85 to 165 CE, based his observation of the solar system on a unit that resulted from dividing the distance around a circle into 360 parts. This later became known as a degree. So Claudius invented the little degree symbol. How cool. Go Claudius. All right, this lovely instrument is called a protractor. Okay, hopefully you've seen it before in your younger grades. And so the number of degrees is in an angle is called its measure. Okay, so here is how they created angles. So I'm going to use this tool strategically. Determine the measure of each angle. So I have AOB, which is this acute angle here. So how you read it is it started at 0 degrees and then it went all the way up to 50. So notice I don't look at the 130 because that would be an obtuse angle, and since I know this is an acute angle, the answer is going to be 50 degrees. Okay, I'll try another one for y'all. Let's look at EOD. So EOD, again, is over here, and so it's this acute angle in green. So I'm not going to look at these large numbers because those don't make sense. I'm going to look at these smaller numbers on the outside. So EOD goes from 0 to 30, so this is also going to be 30 degrees. Okay, let's look at this part B, and then I'll let you guys try it. So BOC is this acute angle here in blue, and so notice it's not starting at 0 this time. So I'm going to have to do a little bit of math. Doesn't matter which side you look at, the smaller numbers or the bigger numbers, but I have a 50, and then I have a 90. So I have to ask myself how many measurements went from 50 to 90. You would subtract the two to get 40. All right, so that's kind of how you use a protractor to solve. If you're finding not starting at 0, you're going to have to add or subtract them. And then if you're starting at 0, you can kind of count up to Z. All right, so y'all try C, E, and F, and then we'll see what you got. Press pause. I paused myself. All right, so your answers were 100 for BOD, 90 for AOC, and F was 130. So let me talk about F real quick. So it's an obtuse angle, and so that's why I did not say it was 50 degrees. I went with that bigger number of 130. And then BOD might have been a little tricky because it's kind of in the middle. You could have found this part of the angle and this part of the angle and then added them up together. Or you could have counted by tens. So like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So kind of some few ways to do that. All right. So that is how you use a protractor to measure angles. If you don't have a protractor at home or with you, totally fine. You really don't need to know how to do it. All right. So the protractor postulate. To each angle, there corresponds a unique real number between 0 and 180, and that is called the measure of the angle. So we're dealing with angles only between 0 and 180. Okay, kind of like a straight line. The measure of the angle is formed by pairs of rays, and it's the absolute value of the distance between their associated numbers. Okay, that's kind of what we just did. All right, so that was nice because they put the protractor for us. Let's take a look at when you have to use a handy-dandy protractor. So you would put the little dot, the vertex, in the center of this protractor, and then you would line up nice and neat on the bottom. Okay, so then if I'm, let's see, T, Q, and P. I'm not going to do that one yet. I want to do TQR. So TQR would be this angle here and this angle here. So you have to kind of extend it to see what it hits at, and it looks like it hits at 25 because it's in between the 30 and the 20. So we'll say that angle is 25 degrees. Let's look at RQ and P now, since my angle is already here. So RQ and P, if I extend that out, it's an obtuse angle, so I'm going to go with this larger number of 140 degrees. Okay? Now to find the other angle, I first need to rotate my protractor to get this nice neat edge to line up with it. So I'm going to make this kind of my new 0. And so T, Q, and P, whoop, I can now, let's see, that went from 0 to about, oh, that's in the middle, I think, so 115, 115. Okay, so you can totally rotate your protractor to figure this out. We could have also, you know, counted from here to here and subtracted those numbers. Up to you. All right, so I have 115, 25, and 140. Using your results from this, describe any patterns. So maybe you noticed that 115 plus a 25 gets you your total of 140. Okay, so very much similar to angle addition postulate. This part plus your other part is going to add up to your entire thing of 140. Okay, so the two smaller ones, angles add to equal the large one. Okay, and that will always be true. Part plus part equals whole. All right, and that's called the angle addition postulate that we're going to talk about. So given that point D is in the interior of ABC, so in geometry, they could be mean and not give you a picture, or you have to draw it. Okay, so you get to pick your favorite angle. I always pick an acute angle. I don't know why. And I'm going to draw a ray coming out of that vertex, and it says D is in the interior, so D is going to be the point on the inside of your outside angle. ABC is your total angle, so you could put A here, you could put C there, but you do have to make sure B is the vertex angle where they meet ABC. So that is how you create an angle addition postulate picture if you were given words. And I'm a visual person, and I suggest drawing it every single time. Describe the measure of ABC without measuring if you are given the measures of ABD. So if I was given the measure of this, and then DBC, which is the other part. So it's basically asking, how would you figure out what the total was if you knew both parts? Okay, and so you would add them together. And so I would say the measure, whoop, not working. I'm going to color code this for y'all. So the measure of the smaller angle in red, so ABD, plus, I'm going to switch to purple now, the measure of angle DBC. So my part plus my part, I'm going to switch back to blue, is going to equal the total, which is the measure of angle ABC. Okay? So again, part plus part equals your total. All right? And that is the angle addition postulate, which is so similar to the segment addition postulate, but we have angle symbols and we have 3 letters. All right? Let me know if you have any questions. Otherwise, we're going to practice. So, maybe you can do this entire page without me, just by me saying that, but I'm going to try a few examples. All right. So it says P is in the interior. So I'm going to draw a picture. I have X, Y, and Z on my outside. Make sure Y is the vertex, and then you have P on the interior. Now I'm going to label my picture. It tells me that X, Y, P, X, Y, P. I'm going to give an angle mark over here. Instead of highlighting it right on the inside, 25 degrees. And then it tells you P, Y, Z. I'm going to put 2 angle marks over here to say it's different. It's 50 degrees. Find the measure of X, Y, Z. So I'm looking for the measure of the entire thing. So I'm just going to add 50 and 25 together to get 75. Okay? And that's it. So it's nice and simple when you just have numbers. But it's obviously going to get a little harder. All right? On part B, I'm going to draw another picture. M is in the interior. So I have M on the inside now. My angle is RTD. I'm going to put T at your vertex. Let's see what they give you. They give you that RTM is 40. And then it gives you RTD, which is the entire thing. So how I I draw like a big arrow connecting them. The entire thing is 65 degrees. Okay? And so now I'm looking for this smaller part, which is over here. Okay? So basically 40 plus what will get you to 65. So you're going to subtract the 2 to get 25. Okay? So drawing a picture is beneficial for sure. In the angle addition postulate, part plus part equals whole. If they give you the whole, subtract it. All right. Let's move on to some algebra. Let's get crazy. All right, I'm going to draw a picture again. Always draw the same angle. I don't know why. I have H in the interior this time of EFG. All right, EFH. Time to label. EFH. First part is 75. HFG. 10x. Whole thing. 20x minus 5. All right. So now I have my part and my part and my whole. So I'm going to write a very long equation to solve this out. So part plus part equals whole. And then you're going to solve it. All right. So I've got variables on both sides. 4 ways to solve this. You get to pick. I'm going to subtract 10x. You can do something different. 20 minus 10 is 10x. Drop down your minus 5. Drop down 75. So now I'm trying to get my numbers to the opposite side, so I need to add this 5. You would get 80 equals 10x. Divide by 10 to get 8. Okay? So my x value is an 8. All right, after this, I can find the measurement of all of them by substituting, but I'm ultimately wanting to find the measure of H, F, and G. H, F, and G is this part over here. So I'm going to substitute 8 in for your x. And so we would substitute with parentheses and multiply to get 80. All right. If they wanted you to find the entire thing, you could also substitute 8 into this equation, or we could add the 75 and the 80 together to get our total. All right. That's angle addition postulate. There's one more problem, a little tricky, but just numbers, so no equations. So see if you can try part D and find the measure of these 3 angles if you know that the measure of AFB is 60, and we'll go over it. So press pause and try it on you. So for your answers, you should have got 105, 75, and 44. So to get 105, it wanted AFC, which was it just wanted the green angle plus the red angle. You add them up, you get 105. The tricky part was probably finding AFE. So you kind of had to turn your head to the side and notice that the red angle plus the green angle plus this blue angle that I didn't know all make a straight line. So supplementary, and so they're going to add to 180. And so I said 180, take away 161, take away 44, and that'll give you what's left over for this other part to be, which is 75. Okay, so that's an example of when 3 angles add up to 180 degrees. For EFD, you could have used this 75 again and the 61 to look at a linear pair, or you could have said, hey, they're vertical. So for example, this red angle 44 and this angle across, they're vertical, so they're the same measurement, they're congruent. And so you could have got 44 that way. Or like I said, we can ignore this line here and then look at the linear pair going this way. And so the 61 and the 75, take those away from 180 to give you what's left of 44. Up to you. All right. So that is an angle addition postulate. Biggest things, make sure you draw a picture to visualize it. Make sure you label it. And then use your knowledge of part plus part equals whole. All right. Let me know if you have any questions. Otherwise, part 2 is on angle bisectors. Have fun.